This is AS Pure Maths Notes. We are looking at quadratic inequalities. We've also just finished the discriminant, which is going to come into this example here as well. This is from Unit 3. Find the range or ranges of values k can take for this equation to have real roots. If this equation has real roots, then the discriminant must have either one or two distinct roots. So let's take that down in a wee sentence. Real roots implies that the discriminant has one repeated or two distinct roots. Therefore, b squared minus 4ac must be greater than or equal to 0. Where is the a, the b, and the c here? This is kind of hard to sort of navigate, I suppose. So the a is always the x squared bit, so where a is equal to k. Our b is the x bit, so it's minus 2k. And then our c is the number bit. Now I know this seems a bit weird, but there's no x with either of those, so that's going to be minus 3k minus 12. So our b squared then is going to be minus 2k squared minus 4 upon k upon minus 3k minus 12 greater than or equal to 0. Tidying this up, I get 4k squared, and then this is taking away the 4, so it's all going to turn into a positive, I think, because the minus here and the minus here. 4k times the 3k, so that's plus 12k squared, and then plus 48k, and that's greater than or equal to 0. That gives us 16k squared plus 48k greater than or equal to 0. Factorizing gives me 16k upon k plus 3, isn't it? Greater than or equal to 0. So my critical values then are going to be there 16k equals 0. That gives me k is 0, or else k plus 3 equals 0. So k then is minus 3. So if we set up our wee table, then we can see what values we're looking for. K, one of them then is 16k, and the other one then is k plus 3, and then our solution is 16k upon k plus 3. Our critical values are 0 and minus 3, so I want something minus 3, k in between minus 3 and 0, and then k greater than or equal to 0. So something less than minus 3, for example, minus 4, that would give me a negative. In between 0 and minus 3, for example, minus 2, that's going to be a negative. And greater than 0, that's going to be a positive. Smaller than minus 3, minus 5, for example, that would be a negative. In between minus 3, minus 2 would give me a positive, and then that gives me a positive. A minus times a minus is a plus, a minus times a plus is a minus, plus times a plus is a plus. And we want to know where this is greater than or equal to 0. This is greater than or equal to 0 means the same as where is this positive. So therefore 16k k plus 3 is greater than or equal to 0. This is positive here and here. So for k less than or equal to minus 3, or k greater than or equal to 0.